Hi everyone, my name is Marian Novotny, and together with Yassin Raman, we would like to present Siembol, an open source real-time security information and event management system based on open source technologies. Let me introduce myself and Yassin. I'm working as software engineer at G Research, where I'm developing applications for security monitoring and intrusion detection. And in past, I worked as specialized software engineer at ESET, where I was responsible for designing and implementing network intrusion detection systems, which were integrated into various ESET products. I did some research in security, where I focused on analyzing and designing security protocols. Yassin is working as a software engineer at the G Research, where he's focusing on deployment and monitoring of security data processing applications. In past, he worked at Cisco, where he developed large-scale data processing applications. When I joined G Research, the team used Splunk for security monitoring. Because of the expensive license, the team decided to build a custom security data platform based on open source technologies. Apache Metron was chosen as a core component of the platform, and we started implementing missing features and plugins in Metron project. We recognized the limits of Apache Metron after using it in production, and the problems were mainly in poor configuration management, which doesn't allow us to scale. And we decided to start implementing a custom data processing framework in order to replace Metron internally. The transition was not easy because we needed to replace component by component. And at some point, Metron was moved to Apache Attic, and at the same time, we decommissioned Metron internally. And we hope that this brings the opportunity for Siembol to become an open source alternative for expensive SIEM tools. After writing documentation and maturing the code base, we decided to open source the project and contribute back to the community. Moreover, we prepared Helm charts for Kubernetes deployment of Siembol and its dependencies. In Siembol architecture, we followed data pipelines from Apache Metron project, but we added components for alerting and incident response, which are missing in Metron architecture. The log after ingestion is normalized by a parsing application. It's normalized to flat JSON with common fields for timestamp or IP address. The event can be enriched by an enrichment component. For example, we can enrich an IP address by DNS name. The enriched log is then evaluated by an alerting component, and escalated alerts are integrated with incident and response tools by Siembol response component. I consider Siembol UI as the biggest improvement over Apache Metron. If we would like to scale to thousands of configurations, we need to have configuration management interface with a clean separation of duties and auditability. It should support validation and testing configurations before they are deployed into production. This is a screenshot of the Siembol UI landing page, and the list of services on the left side is based on user permission and authorization. We distinguish between store and release of configuration. In the store, the user can edit and save configuration without releasing it into production. The Git repository is used for storing configurations, and all changes are committed by UI with the user as a committer. This way, Siembol provides a clean, auditable history of changes. At some point, the user can promote the change and release the configuration. And during this process, the pull request will be created in the Git repository. And after reviewing and merging, the configurations are released into Siembol components. Configurations are stored in JSON format and edited by web forms. Moreover, Siembol UI supports testing configurations and creating persistent test cases that are stored in the Git repository. Test case includes input for testing the configuration, along with assertions that are evaluated during evaluating a test case. This functionality, in our opinion, helps to mitigate errors in configurations before they are released production. Siembol UI is using Git for storing configurations. All configurations are edited by web forms and stored as JSON files. Siembol UI supports OAuth2 OIDC authentication and authorization. Authorization for a service is based on user group membership. Siembol UI supports high integrity requirements. For configuration change, a pull request is created, and the pull request can be reviewed before merging and releasing into Siembol components. When we implemented parser in Metron, we need to write a Java code, compile, test, and release it into production. This process takes time and is error prone. So we have decided to build a custom parsing framework in order to speed up onboarding a new data source. A parser is created and edited in Siembol UI, similar to other configurations. First, a log is parsed by a basic parser, such as syslog. Then chain of extractors is executed in order to extract important fields from the message. And finally, the fields are cleaned by transformation functions, where we can normalize values or field names, rename fields or filter fields, or the whole message if it's not needed in further processing. This is an example of a simple parser for parsing AWS CloudTrail messages. As you can see, this is a JSON parser, and we are using timestamp field event time in order to parse a timestamp for the message. And we are cleaning message by deleting fields, which are starting by request parameters resource pattern. Parser can be integrated in a single parsing application or can be combined with other parsers in a router parsing application in order to speed up onboarding a new data source. In this topic router parser, a parser is selected according to an input Kafka topic, but also Siembol also supports routing application based on Kafka message headers. This approach allows us to maintain a big parsing applications that collects and aggregates logs from multiple data sources. Metron is using HBase for storing and retrieving enrichment tables. We had issues with the stability and performance of HBase tables in the Metron enrichment implementation, and we have decided to use only in-memory tables that are sufficient for our use cases. The tables are stored on local HTTP web server that is part of a Siembol Kubernetes deployment. Enrichments are defined in rules, which are edited in Siembol UI, similar to other configurations. This is an example of rule for enriching an IP address by a domain name. The rule is applied after matching the field IPDST-ADDR, and the table with the name DNS is joined with the event using the IP address as a key. If the table contains the IP address, the event is then enriched by the field DNS name. Metron has no dedicated component for alert escalation. We decided to build a custom framework for real-time stream evaluation of detection rules without need to index events. This approach allows us to scale to thousands of detection rules that can be difficult in a solution with indexing and querying the data. Siembol alerts are edited in Siembol UI, similar to other configurations. This is an example of AWS failed authentication rules. And in this rule, we are matching event name field with console login pattern and error message field with failed authentication substring. We are adding a correlation key tag with value from user identity principal ID variable. Siembol alert can be escalated directly to Siembol response component, or it can be used for correlation with other alerts in the correlation alerting engine. Correlation alerts are edited in Siembol UI similar to other configurations. This example of AWS brute force login rule. And in this rule, we are correlating AWS failed authentication alerts in 1 minute time window, and the threshold for triggering rule is set to 10. Siembol UI supports importing a Sigma rule into Siembol alerting component, and in our opinion, supporting open standard formats for SIEM detection rules is more efficient, and the rules created by a community of security researchers can be easily imported into a Siembol alerting engine using UI. This is example of importing the rule using UI, and first we need to define attributes for translating the Sigma rule, and then we can download, copy, and paste existing Sigma rule into this dialog. And after clicking to import, the rule is translated into a Siembol alerting notation, and later we can edit and improve the rule in a Siembol format. Siembol response is a component for integrating incident response tools with escalated Siembol alerts. The integration rules are defined in Siembol UI by a CSERT team in order to automate their response to an incident. It supports enriching alerts by doing ALK, LDAP, or virus total searches. Moreover, it allows to filter alerts in this stage. Siembol response has a plugin architecture that allows an easy implementation of custom integration if needed. Siembol was designed with aim to scale with number of events and number of configurations and quickly adapt to changes in technologies. Siembol UI follows microservice architecture, where single-page application is developed in Angular and REST API is developed in the Java Spring Boot. Siembol UI is using identity provider for authentication and authorization, and GitHub for storing configurations and managing pull requests. Siembol REST follows a modular architecture, and to validate and test configurations, it includes the same models which are used in Storm applications. One exception is Siembol response with the microservice architecture. This is because Siembol response supports loading plugins, and we would like to load them only in one place. Siembol follows desired state pattern in order to release Storm topologies, and this state is computed by Siembol REST from configurations which are stored in Git repositories. These configurations are synchronized using Zookeeper, and the Storm topology manager is component for killing and starting topologies based on the desired state. Siembol can be deployed with an external Storm cluster and orchestrated from Kubernetes using Storm topology manager component. Moreover, we prepared a Helm chart for Storm deployment, and we are using Kubernetes deployment internally at gResearch. Siembol REST computes desired state of released Storm topologies from configurations stored in Git repositories, and the state is synchronized in Zookeeper. And Storm topology manager using Storm UI API to kill a topology, or Kubernetes jobs to launch a new Storm topology. We are using open source Bitnami charts for Zookeeper, and we prepared an open source Helm charts for Storm deployment. The Storm state is stored in Zookeeper, except data stored by Nimbus, such as jar files or metrics. This way, only Nimbus is defined as a stateful set, in contrast to Storm UI and supervisor that is defined as a deployment. Workers are launched in supervisor deployment, And this way we can easily scale up with number of replicas in supervised deployment if needed. Siembol is deployed in multiple complex applications, which depends on various kind of infrastructure components. This way, it's very important to monitor the whole Siembol processing pipeline in order to detect failures and automate the response on an incident. Monitoring can also provide observability for Siembol users. Prometheus is a central component of Siembol monitoring. It's scrapping metrics from storm topologies, from Kafka log monitoring, and from Siembol heartbeat service. Siembol heartbeat service is regularly sending messages for processing by all Siembol components. And the service also computes the latency of the processing. Operational incident can be detected using Prometheus queries, and Siembol REST API can be used for restarting storm topologies in order to automate response to an operational incident. Siembol CI/CD pipeline on public GitHub repository builds 8 Docker images, and it releases Java packages to central Maven. We are publishing Kubernetes Helm charts in order to easily deploy Siembol on Kubernetes cluster. Siembol architecture allows us at GR deployment to process 250,000 events per second, which is around 20 terabytes of raw logs per day, with an average 250 millisecond total latency after processing by all components. We are onboarding 97 data sources and evaluating around 650 detection rules. This is computed in 45 Kubernetes pods, but we believe that this architecture and deployments allows us to scale with deployment in order to process more events and more configurations.
So as part of the quick start guide, we have a few scripts that will help you install Siembol. So the first step is to install Minikube. After this, you can run the dependency script, which will install Apache Storm and Kafka. And then we have also created a config repository, which includes some basic parsers, enrichment alerts, and you can fork this repository and it gives you a good starting point. And you also have to create a GitHub token. This is for Siembol to communicate with your config repository in order to like create PRs and update configs. So now we can run the demo install script, which will ask you for your GitHub details, your username, GitHub URL, and then yeah, you have to open paste the token, and this will create a config map with your GitHub details and a Kubernetes secret with a token. After this, you're now ready to install Siembol. This will install config editor REST, Siembol UI, storm topology manager, response, enrichment store, and Siembol monitoring, which I will explain a bit more in detail a bit later. So we'll wait for this to be running. And then now we can go to the UI. And you see a list of these services on the left side. Click on parser config. We have bin event logs parser. This is a simple syslog parser. You can see parser attributes. We can add parser extractors. You have transformations that you can add. You have test config. You can add the log message to test. We have a few test cases. This is a log with failed login event. And you have a few assertions. You can run the test case, see it passed. You can also run all test cases in one go, like this. You can click on one test case and see the output. go back. You can also edit config and create a PR, which will then update the config repository in Git. So let's add a dot and an exclamation mark and click submit. This will be validated by the backend. Submitting config, and then you have to click back, and then we can see the diff. You see the change there, and you're ready to upgrade. Release PR. Then this will create a PR in your GitHub repository. So if you go there, you will see that the version has been increased by 1 and the change with the dot and exclamation mark. We have also enrichment. We can enrich certain fields. So for example, host names. So if you have an IP address, we can enrich it by the host name by creating a mapping. It's called a table mapping, and you specify your event field name. So if you go back to the install script, you can create an enrichment table. This will create a hostname.json file, and if you go to a test case, you will see the table mapping between the IP address, which you see here, 1234, and then the host name, which is test name. So if you run this test case, you will see in the output that it has been enriched with the test name as the host name. See, test name. And this was because the IP address of this log message was 1234. We go to alert. We go to win Mimikatz. We can see source type. We can add matchers and tags, root protection. We can test config, and we have one test case containing a log that will match Mimikatz logs. If we run this test case, you will see then the output. So then we can now go back. Siembol also supports to import Sigma rules. So this is from the Sigma repository in GitHub. We can copy this Sigma rule, and the only thing you have to add is the source type, so sysmon, then import. This will import the other config, and you can see the source type. You have matchers. You can change this, modify it as you wish. Same with the tags and root protection, and then you can test the config in order to validate. If we go back to the install script, we can now go to the Storm UI, which will show the topologies we have. So one for the parsing app, Siembol alerts, and enrichment. So the next step is to install the monitoring pieces. So this will install Grafana, Prometheus, and the Kafka-like exporter, which is just a tool for us to monitor Kafka lag. Wait for this to be in running states. Yes, now we can go to the Grafana dashboard. And if you go to Siembol, you will see the consumer group lag. So you see heartbeats. That's the only thing that we have running at the moment. And then we have, if we just change the last 50 minutes, this heartbeat is a component that runs every minute, and it goes through all of the components of Siembol. So goes through parsing, goes through enriching, then response, and you can see the latency for each of these Siembol components. So you have the total Siembol latency as well here. And it is a good way to measure the whole platform's latency with this heartbeat message. And now we can install Kafka UI with Capdrop and a Kafka client. So just copy and paste this to get the IP address and port number. Wait for it to be in running state. Then we can exec into the Kafka client pod and connect to the broker with our Win event log topic, and then find the Mimikat log message, which we'll send. This is the log message. Copy and paste this. And then now we can go to the Capdrop, which is the Kafka UI. And we'll see in the topic Win event logs. We'll see the message here. One message, and this is the message that we sent. If you go back, we can then see it got consumed by the Siembol.enrichment topic. And these are like all of the heartbeat messages, as I was talking, 1 per minute. And this is the Win event logs message, and we see it's a flat JSON. And then it goes to Siembol.indexing. And it's the same message. You see it here, flat JSON. And all of the other messages are like the Siembol heartbeat messages. So you see this, as I said earlier, it goes through and parsing, enrichment, response. So we can go to Siembol.response.heartbeat. This topic will then have the heartbeat messages, and you see that the response rule name is here. If we go back to the quick start guide, we can now generate a bit more traffic. So if we run this, we will then have a bit more event logs and CloudTrail log messages that will be produced. And if we go to the Grafana dashboard, we will see a bit more traffic and some more interesting data. So let's wait for this to run. And you see the 2 pods there, CloudTrail and event logs. You can now go to the Grafana dashboard, and immediately you see that the lag has increased. We are producing about like 500 messages per second. And you see the parse messages, the rate per minute is increased, and the total parse messages is like 8K. And you see parse messages per source type, CloudTrail as 3K, Win event logs 6K. And if we go down, as you can see now the latency, how it has been going as we have been running Siembol. And you can see the latency for each component, and you see it's increasing a bit now with the additional traffic. So now I want to hand it back over to Marian.
We prepared quick start guide with deployment on the Minikube and a Git repository with Siembol configurations. If you decide to try Quickstart Guide, feel free to discuss issues, provide feedback, or ask for help using GitHub discussions. Siembol is not a one-man project, and I would like to thank to all Siembol contributors. If you are interested in the project, please visit our webpage, siembol.io, or have a look at the Siembol GitHub repository. Thanks for attending the talk.